What is specific heat capacity? It is defined as the amount of energy needed to heat substances up, and it can also be thought of as a measure of how much heat energy is needed to warm the substances. In addition, specific heat capacity can be used to quantify the relationship between the amount of heat added to a given amount of a substance and the corresponding temperature increase. Alright, so let's take a look at the equation that you guys have seen before in lecture. Q equals m times C times delta T. Now what are those variables represent? Q represents the amount of heat energy gained or lost by a substance, and typically will be in the units of joules. M represents mass of a substance, and it will be in grams. C will be represented as the specific heat capacity, typically in joules per grams Celsius, and delta T, which is your change in temperature, will be in Celsius. And note that delta T is the difference between the final and initial temperature, and it can be rewritten as T final minus T initial. Here's an example that we can work on together. How much energy would be needed to heat 450 grams of copper metal from a temperature of 25.0 Celsius to a temperature of 75.0 Celsius? And we will be needing the specific heat of copper at 25.0 Celsius, which is 0.385 joules per gram Celsius. So given the two temperatures, you can find the change in between and you get 50.0 Celsius. Given mass, a specific heat capacity, and the change of temperature, you have enough values to plug into the equation Q equals m times C times delta T. And plugging in your values, you get Q equals to 8,700 joules. Now remember, you need the right sig figs. You need to report your answers with the right sig figs. Just keep in mind of that.